What if I told you that in the next 20 minutes, you'll build something that most developers spend weeks learning? A full content management system without writing a single line of code. Let's go! Hey, Alex here from Grit AI Studio. Welcome back to Vibe Coding with Cursor, where we build real projects without needing to become full-time developers. Last time, we built our first real app with login, authentication, and a protected dashboard. Today, we're taking it one step further by adding real dynamic content to our application and giving ourselves a way to manage it easily. We're building a content archive from scratch, powered by Supabase and vibe coded entirely with Cursor. And no, we're not writing a single line of code. Whether this is your third episode or your first, this video stands completely on its own. This kind of feature is often called a content management system, but let's skip the jargon. What we're actually doing is simple: saving content in a database and showing it to our users inside the app. And once you know how to build this, you can use it in any app idea you have. We're building an AI running coach app, but no matter what you're building, these are the tools and workflows you'll use to go from idea to real working product. We're on a learning journey in this series, and a lot of videos show AI-assisted coding as something that works on the first try every time. But that's not reality. In this video, we'll cover a few things that will likely cause some trouble. And instead of cutting it out, I'll keep everything and explain how to deal with the challenges that you might face. Let's get into it. Before we start building, we need to make sure we can differentiate between admin users and regular users in our app. The simplest way to get started is by adding a role field to each user's metadata. Supabase makes this easy by letting us store custom metadata alongside each user profile. We can even ask the AI assistant in Supabase to help us out with all the required changes. Help me differentiate between admin users in my application and regular users, so that I can have an admin page in my app where only admin users have access. Now let's follow these steps. We can execute each query and check that it was successful. Sometimes we'll encounter errors. When this happens, we can simply copy the error and ask the assistant to help us out. Most of the time, it'll fix the mistake and we can just run the query again and check that it worked. The assistant also provides us with some guidance as to how we should implement this logic in our application, but we'll come back to that later. Now, in our case, we already have a couple of users, and the logic here will work for new users, but we need to update the roles for our existing users. Let's ask Supabase for some help with that. We can now head over to the new profiles table, find our users, and change the admin flag to true for our admin user. Here I'll keep one user as a regular user and one as admin. Now we can start building admin-only features like adding or editing content, while regular users will only be able to browse. As we go, we'll improve this setup, but this gives us a solid foundation to build on. Now let's say a few words about how security works in Supabase and how to think about protecting your data. There are a couple of basic strategies that you should be aware of. The most important is row-level security, or RLS. This is Supabase core access control system. With RLS turned on, you can define exactly who can read, write, or update which rows in your database, based on things like user ID, role, or session. You can use user metadata, like the role field we just added, to control access in your queries and RLS policies. As an example, only users with the admin role can insert new workouts. The second part is front-end logic. On the front end in our application, you'll also want to check roles before showing or allowing actions, like hiding the Add Workout button unless the user is an admin. This doesn't replace RLS, but it improves the user experience and avoids confusion. It's important to note that Supabase does not protect your data unless RLS is explicitly enabled for each table. So whenever you create a new table, like we'll do next, you should turn on RLS right away. We'll show you how that works in a minute. So now that we've got a basic role setup in place and we understand the security model, it's time to build our first real feature. Let's go. We'll start by creating a new table in Supabase called Workout Templates. This is the content we'll use for our example, but it could just as easily be notes, articles, recipes, or bug reports. The structure's the same. AI is great at helping us with this as well. So I'm going to go and make use of auth and ask it to suggest a suitable data structure for workouts. You can of course replace that with whatever you're building. We will provide some details about what we're building here, as context is king and we get far better results that way. I'll also add my thoughts as to what I mean by workouts and what I envision for our solution. We'll ask it for the SQL script to generate our tables in Supabase and also ask for some sample data to get us started. No need to manually create a bunch of workouts for our library when we can just ask AI to do the heavy lifting for us. In no time, we have the SQL required to set up tables in Supabase and 50 workouts ready to import into Supabase from a CSV file with the recipe to go along with it. Now let's head over to Supabase. We'll copy the SQL and head over to the SQL editor in Supabase, paste it in and run the query. Here we also have some categories defined by auth that are also going to be created for us. Make sure that there are no errors and we should be good to go. Now we can head over to the table editor to review our newly created workout categories and workout templates table. The last thing we need to do is download our CSV file from auth and import the data into Supabase. And it's that simple. Now that we have our data ready, we need to turn on RLS for our new tables. Hit Enable RLS for both tables. Now we need to define appropriate policies. This is what determines who can do what with the data in the tables. We can use the AI Assistant in Supabase to help us, or we can ask auth. You can also do it manually, but that might be a bit advanced for most people that have never built an app before. Let's turn to auth and ask for some policies. We should describe what we want to achieve, who should be able to do what, and so on, so that auth can give us the best possible advice. We can then run this SQL in the SQL editor in Supabase. Now we can check the auth policies on each table to make sure that they are defined and active. Interacting with Supabase from Cursor is a whole lot easier if we use the Supabase MCP. Now, we strongly recommend using Supabase MCP in read-only mode to avoid any security vulnerabilities. This is still very useful as we can read from Supabase and also have it help us create the appropriate type definitions in our code. We have a separate video showing you how to install this here. Normally, you would need to set up the connection to the right table, create type definitions in your code. With the Supabase MCP, Cursor can do all the work for us. So let's look at how we can do this when we add logic to show our workouts in our app. Again, as a rule of thumb, we should always use read-only mode when using the Supabase MCP to avoid known security vulnerabilities. Now that we have our workout library in Supabase and the row-level security policies all sorted out, let's bring this to life in our app. We'll create a new page at /workouts that fetches all our workouts and displays them in a simple list. This will then be the user-facing archive. For this, I will intentionally use the auto model and some prompts that are not necessarily perfect. This way we can cover some examples that you'll very likely encounter yourself on your journey and hopefully be better equipped to deal with it without becoming too frustrated or discouraged. Remember, we're learning step by step in this build series, but if you ever get stuck, you can always drop a comment below or in our school community. Let's go. Now let's ask Cursor. Create a new page at /workouts that fetches and displays workouts from our workout templates table in Supabase. Only logged in users will be able to access this page. Users should be able to browse the different workouts, and clicking on a workout should open a nice looking page showing all the details about that workout in a responsive layout. Create the necessary type definitions. We'll also ask it to use the Supabase MCP to review the table definitions and tag the rules file that we created earlier. Now Cursor will generate the page, connect to Supabase, and build a layout all in one go. And again, if you're building something totally different, just change the type of content, the pattern is the same. Now, I noticed that Cursor puts the type definitions for our data in the file that it created. But in order to avoid having to repeat these definitions several places in the code, I ask it to follow dry principles. Essentially, don't repeat yourself. It will then create a types.ts file where we can keep our data definitions in one place. Now let's run this and see if we can view our workouts. Look at that, it works! Can clearly improve a bit on the look and feel though. Let's just take a screenshot and ask Cursor to improve the styling. And there we go. Now it's starting to look pretty good, with literally no effort at all. We're not explaining or going through all the code, as this is a series meant for people that want to learn how to build without knowing how to code, and instead of explaining every aspect of code, we're learning step by step. Over time, we're learning more and more about how the code works, and it becomes easier to spot mistakes and guide the AI on the right path. If you want to understand more straight away, simply ask Cursor to explain the code for you. In a future video, we'll cover more details around testing, debugging, and refactoring with AI. Now, this is a great starting point, and we can of course do a lot more with this later on, making it even prettier and user-friendly. But for now, let's commit our changes and move on to the admin page. I like to commit changes after every feature or significant change we make to our code. That way we can move on, and if anything fails or we get stuck, it's super easy to roll back to our previous working version. We simply select the 3 files that we have changes in, stage them, generate a commit message, and then hit commit. Now we're going to build something really useful. A page where we can manage the content, in our case adding new workouts, editing existing ones, or deleting them. Let's ask Cursor, still using the auto model, to create our admin page and a page to manage the workouts. Now let's create an admin page at /admin and a subpage at /admin/workouts that lets me list, add, edit, and delete workouts from the Supabase table. Only users with the admin role should be able to access the admin page and any subpages. We'll later expand the main admin page with more functionality. Cursor will generate a full CRUD interface for us, wired up to our backend. CRUD is short for create, update, delete. Now, I wasn't very specific, but you can see that Cursor searches and figures out that admin users are identified with the isAdmin column in our profile table. Let's run it and try this out. We will log in with our admin user. But apparently, something is not yet working properly and we appear to not have access. Let's double check that we have the admin flag set to true. Okay, so that's not the issue. But we forgot to set up the auth policies for the profiles table. We only did that for the workout tables. Now, this is a common thing to forget, but in case you're stuck and did not think of that, the trick is to add some logging to your code where it said access denied. You can, for instance, print the error message from Supabase in your console, and you should see an error code that you can paste into the AI Assistant in Supabase, auth, or your favorite AI Assistant. A typical symptom is that you get 0 results back from Supabase, and then chances are that it's because of missing or wrong RLS policies. Let's just ask auth to create a policy for us. We should review the logic and make any corrections if we spot any logical errors. In this case, I want to make it clear to auth that users should be able to read the profiles and probably update information in their own profiles, but regular users should not be able to make themselves admin users. That would be a significant security loophole. So now we can copy our policy and paste it into Supabase. In this case, we're getting a few errors in Supabase. So let's just copy the error codes, ask auth to correct it, and finally, it runs successfully. Now we can try logging in again, and there we go. Now we can see the new pages to manage our workouts, but for some reason the buttons are not working as expected. Let's ask Cursor to help us implement this functionality. We'll ask to add and edit workouts in a new page. Cursor actually gave us several options here, but I think it makes sense to do this in a new page for now. Now it's asking how we would like to implement the logic for editing. We'll just say that we want the same approach for editing, using the same form essentially. Okay, let's try it out. Unfortunately, we're now running into some runtime errors, but don't worry. Now, often we get away with copy-pasting the error message into Cursor, and we'll try that first, but sometimes this can turn into a spiral down the rabbit hole. But let's go along for the ride for now. Now, the big mistake we're making at this stage is that we're still using the auto model, and we're not referring to a rules file, which would have saved us a lot of hassle at this stage. So now Cursor fixes one error, introduces another, but eventually manages to clear all the errors. But when we try, the buttons are still not doing anything. So we keep going. This time we ask it to follow the Next.js documentation. And now, finally, it works. We can now edit our workouts. Let's try it out. I can then change this one again, save it, and it's updated. Let's try creating a new workout as well. We fill in the details for our test workout. Cursor has even implemented basic form validation for us. And there we have our test workout. We can see it here in Supabase as well. But the delete button is still not working. Let's ask Cursor to implement the logic for this one as well. Cursor in auto mode tries its best, but now we start getting more and more errors. Now, instead of going further down this rabbit hole, let's do a few things. The first thing is to roll back to a previous checkpoint in our chat. We want to step back to a point where we know our code was working before all of these errors kept showing up. We can scroll up and hit the Restore Checkpoint button. Then we're going to ask Cursor to explicitly make use of our rules file when trying to solve this problem. And we're still hitting errors. Okay, so now the next step, which we should have done already, is to start a new chat to clear out the context. Going through a lot of issues and running long chats will eventually pollute the context and confuse the model, especially when we're running the auto model. We'll use the same prompt, add our rules, and also reference the Next.js documentation, and we'll now switch to the much more powerful Claude for Sonnet. This model works by reasoning through the problem and even creates its own to-do list that it works through to solve the problem. It's more costly and you'll run out of tokens quicker, but it's definitely worth it when solving more complex problems or building out features. We still have a few more runtime errors that was likely introduced by our auto model that we need to fix with the help of Claude. Now, remember that you can simply copy-paste the error messages and ask it to fix it, but it really helps being specific. So remember to add any relevant information, such as where this error is happening and what you were expecting to happen. In this case, Claude suggests clearing the cache, and that solved everything for us. In essence, old issues were polluting our app, and clearing the cache removed the problem. Finally, the delete function also works. We can verify it by heading over to Supabase, refreshing our table, and the workout is gone. Lastly, we'll fix a few front-end issues so that we have a clean and working application. And just like that, we're managing content like a pro, without writing any code. We managed to make it work, but for the future, we can avoid a lot of these issues if we apply a few key learnings. There's been a lot of talk about vibe coding versus the latest buzzword, context engineering. And in reality, it boils down to providing context, applying structure to how we build and solve problems, rather than just going with the flow with no structure or thought. And that's essentially what we're doing in this series. So what happened here? We added a rule file in the previous video for Supabase that we used successfully, and another one for Next.js. Now, the Next.js file was created with some help from auth, but if you look closely, the rules file are only applied manually and not automatically the way they're currently set up in our project. If we remove the first part here, you can see that the rule logic changes and now applies to any and all TSX, TS, JS, and JSX files. Going forward, these rules will definitely help us avoid a lot of the mistakes that the auto model introduced by mixing practices and even using some outdated ways of doing things in Next.js. In addition to this, we can go even further and actually ask Cursor to learn from its mistakes. Let's simply prompt something like this. Recap the various issues we've been dealing with and write a rule file we can use to avoid these type of issues in the future. Now, this is super useful to do after having struggled with issues and finally finding a solution. The problem when you just ask it to fix is that you risk partial solutions, cluttering and adding new issues, and it can become a really big mess. If we have memories turned on in Cursor, it will also remember this for the future, hopefully avoiding some of these issues for us. Now we've updated rules that we can use in Cursor when we build things in the future. Pretty neat. Now to wrap things up, let's just update the main navigation so users can browse workouts easily. Add a link to workouts on the main dashboard page, styled as a button or nav link. We probably want a nav bar as we're building out our app with more features. For admin users, we also want a link to the admin page on the dashboard page. Now we got a nice fresh navigation bar on our dashboard page, and Cursor even added some placeholders since we mentioned that we'll be building out our app with more features. We were not specific enough though, and you can see that this navigation was only applied to the dashboard page. We probably want a better experience across pages, and we also want better styling on this logout button. Let's simply ask Cursor to fix it. I'll simply ask Cursor to add this navigation bar to all the pages. And there you have it! This makes the app feel complete, and the structure is reusable across anything you want to build. And it's actually looking really good. Let's try logging in as a regular user as well, to verify that we don't have access to the admin page. Everything's working as we wanted it to. That's pretty cool. Now, you can definitely end there, but as a bonus, I would highly recommend doing a final cleanup before we commit our changes and call it a day. Right now, we are repeating some code. We should use components where applicable and follow dry principles. Now all you have to do is stage your changes, generate commit messages, and hit commit. As a final step, I asked Cursor to clean up our routes and make sure all files are organized the same way, after the auto model had messed up a few things for us earlier. And that's it. Now we have a complete workout library that our users can view and we can manage as administrators. Even though we ran into some issues, we hopefully also learned some techniques to deal with it. Let's recap what we actually built today. We managed to build a structured content system with Supabase. We added a user-facing archive at /workouts. We built a full editor for managing content without code. And in essence, we got our first taste of data-powered user experience. This kind of feature shows up in nearly every serious application, whether it's a reading list, inventory tool, or team dashboard. And now you know how to build it. Okay, so let's recap some best practices for you. Make sure you actively use rules in Cursor and reference documentation when you feel the model is getting stuck. This can definitely help you avoid a lot of random outcomes. Always provide enough context. Assume the model doesn't know anything and choose a better model like Claude for Sonnet when dealing with more advanced features or issues. Break down complex tasks and be specific. Avoid too much choice for the model. Another way to be specific is to provide examples. For instance, here's the input or output that we expect or aim to support, and so on. Use checkpoint restore when you get stuck. Roll back to a point you know was working. Start a new chat when it gets too long, and generally when you start working on a new feature. And once you have solved an issue after going down the rabbit hole, make sure you always ask Cursor to recap and to update your rules. In the next episode, we'll add user onboarding and create a user profile that we can use to personalize the app experience. If you like this one, hit like, subscribe, and drop a comment with what you're building. Let's keep building with grit. Thanks a lot for watching, and I'll see you in the next one.